YouTube homepage it is visible. So I think author here is talking about how the YouTube page looks like. So the content creators can upload the videos. When the viewers click play, so they can view the video. I think it is really simple already. And so these are the scale I think which YouTube has as of now. So the monthly active users is around 2 billion. Number of videos watched are 5 billion. The 73% of adults use YouTube. 50 million content creators. YouTube ad revenue. So it has a huge ad revenue as well, right? So these are just the numbers which the author is talking about. And yeah, so what is like I mean, what is the scope which we will see here is uh, the scope of the design. So like basically if we think of YouTube, it would be something like user can go and upload the video and they can play the video, right? Then something like we can store the count of likes uh, and dislikes, maybe some comments on the video. What else? Maybe number of views. So these are some of the questions that maybe we can ask the interviewer, like what is the scope, like what do we really want to focus on, right? What else do you guys think can we use here?
Notifications.
Yeah, notifications as in like the subscribing thing, right?
Yeah.
Okay. mm, yeah, so this looks fine. Let's see like what here is the candidate, which features are important. Upload and watch the video. Then the number of devices, so obviously it would be web browsers and your mobile app. Then how many daily active users. So here I think they are talking about multiple support. And 5 million, right? 5
Yes,
billion, I think 5
5 million daily active users.
daily active users. So this,
Million.
okay, so
So just for clarification, world population is around 8 point something billion, and approx 20%, 25% of them use YouTube
okay,
overall.
interesting. Yeah, so this looks fair. And then how many daily active if we took it, and then daily time spent, like on an average a person is spending about 30 minutes. uh, so we can just do the math, like multiply this and we can get the total time the user is on the platform. Okay, it has to be a multiple geography thing. So uh, so different country, different people can be there. So multi-region support. Okay, then there could be different formats of the file. So like MP4 and HD, something like that maybe. So when you are uploading the video, then there can be different formats. And encryption, yeah, so you need to encrypt the data as well, like we discussed yesterday also, I think, the encryption part. So this is there. So for calculating, like we can have some number in mind, like for doing the capacity estimation, that one video would be I think maximum around 1 GB length. So we can try to calculate the requirements for this. Okay. So now is we can for the storage purpose, obviously you need to store the data. So can you use any third party thing? So building everything from scratch is unrealistic, so maybe some third party cloud services we can use. But here the focus is mainly on uploading the videos and streaming the videos. So are they saying that they are not concerned about the storage?
I think, yeah, they are saying that we can use third party for storage and do not think about if the size increases too much, how will we handle sort of things.
Okay, so I think the most important thing is uploading and this. So these are the, I mean, the features which we are kind of interested in, right? So yeah, maybe these two features basically we are looking forward to upload and play, right? So so basically non-functional requirement means that our system should be highly available and it should be very fast. so which eventually mean low latency. And what else? It should be fault tolerant and scalable, like horizontally scalable. So why I say is horizontally scalable, because when you're designing a system, then this number will increase, right? There would be some growth rate associated with it, by which your volume of the user will increase over time. So we have to consider that also while designing a system. So that is what I think it should be scalable. Then the capacity estimations are here. So somebody is trying to join. Okay, so here basically we are discussing about the estimation. So 5 million users, and each user is watching 5 videos per day. Then 10% of the users upload one video. So total storage, how much storage we need is 5 million multiplied by 10% of these 5 million will use this actual thing. So that is there, and video size is 300 MB. Obviously, this is the average size, although the maximum size is 1 GB. Right. So if you do calculate this, then MB multiplied by million would be around this thing 150 TB or something. Yeah. So that is fairly like the calculation which we are doing. Just these numbers we need to understand, like from the interviewer, like what is expected here. Okay. CDN. So CDN I think is being used for multiple geographies, but let's see like what here they are talking about. Okay, so I think here they are talking about the CDN cost. So for CloudFront, which is I think a CDN service by Amazon, uh, it is charging about $0.02 for 1 GB of data transfer. So that is how they are calculating the cost, I think. So if you imagine, this is a very huge number. So not any service provider can pay this amount of money. So either you have to do some optimization on the CDN thing, or so does that point us to that question where Netflix kind of stores the data on the ISP side, right? Is anyone aware of that?
Not yet,
Yeah, the
but
point of view of Netflix doing that thing is primarily not relying on something like AWS or GCP. Uh, it's more like they want to do it to make their system more reliable rather than cost being the primary factor.
I think Netflix has its own CDN, which is internally using AWS only.
yes, exactly. Like they use their own
I
CDN.
remember the name.
And
Okay. So yeah, so one solution is to build your in-house CDN rather than using an external thing. And what else optimization? I'm just trying to think. Maybe it is covered later, but yeah. So
I think for interview purpose, like we can just mention that, videos that are streamed that can, like frequent videos, let's say like 0.1 or 0.2% of total videos can be cached on like CDN. Yeah.
okay.
Yes, yes. So their CDN actually, they, uh, it works like different ISPs can integrate with their CDN, and uh, so
Okay.
basically users can have a good experience. Basically,
Yeah, okay. So I think here they are talking about the second step. We have established the design scope where we will be focusing on the upload and the play part. And so now existing cloud services we can use, right? And instead of building everything from scratch, so CDN and blob storage service we can use. Yeah, so it's about like how you will store the data. You can store some third-party things for storing the data, maybe the image part or the thumbnails. That is a static data, so you can store in S3. And similarly, the video things you can store in CDN also. Yeah, so that's exactly right. We discussed, somebody called out that Netflix uses Amazon internally, and Facebook similarly uses Akamai, so they don't have to worry about this, right? And so client makes a call, it goes to the CDN to get the data, or not to get the data, but I think it goes for the storage also, right? When you are uploading the video, then it kind of goes there. But is it like when we are making a get call, then also it would be fetched from the CDN?
So mostly
Yeah,
it is for get call only. CDN is just used like a cache. But when you try to upload, it's either directly being uploaded to the blob storage or done through the API server.
Hmm.
After that it is cached through CDN. So you are using CDN for the get cost only, not for the post call.
Okay. So video is actually getting streamed from the CDN. So everything else except video streaming goes through the API servers. This includes feed recommendation, generating the upload URL, updating metadata, and cache. So in the question answer below, the interviewer showed interest in two flows: uploading flow and the streaming flow, right? So now they will deep dive into both the flows. So just to add, I mean, here we have two things.
Just add like one correction. So I mean, so basically, like the videos are streamed. Like not all videos are streamed from CDN, because otherwise, like that will be a very huge cost. So only like very popular videos or like very top videos can be streamed from CDN, and the rest from the like blob storage itself.
Okay.
Also, like you can replicate your blob storage in other regions, maybe in sync or in async mode.
Yes.
Okay.
It's called like mirroring, I
That's
think.
right. Like you cannot store everything on CDN. It will become a single point of failure also, right? You need to store it somewhere.
No, actually, I would say CDN is much
Costly.
more efficient in terms of cost, and also CDN replicates everything by themselves. So it's a managed service. So it's highly unlikely that your data will be destroyed if you have put something on CDN. It has a lot of available servers in every region. Also, I want to point it out is that the highly famous videos are essentially cached at the device only. I have seen there is a smart download section in YouTube where they beforehand download the videos for me on the app itself. So client also can work as a cache, not only streaming it from the CDN. That is like one more layer, yeah, before it.
Okay. So I haven't heard about this smart download something which you mentioned, but
It's a new feature by
okay.
YouTube.
So is it
And by new, I mean it's a couple of years old, but
so does
relatively.
that mean you store everything at the client side, like the cache all the
No,
videos?
smart download is something YouTube basically caches some of the recommended videos for you. So whenever you go offline, you have at least some videos to watch.
Okay,
So it
understood.
does it for you. But you can also download some videos you are interested in, right? And that will be downloaded at your end, so you can view it even if you are offline.
Okay, but
So and I agree with him also. CDN is not single point of failure. It's a reliable service. We can use it. The only reason we won't be storing all of our videos in CDN because of the costing only. So maybe the recent videos that are 1 month old, we can store in CDN and those all. But let's say there are some very unpopular videos, something, we can just fetch it from blob storage.
okay, understood. So yeah, makes sense. Like I mean, here we are basically concerned about two things. One is the CDN, and another thing is the blob storage. So and maybe this guy is the cost factor which we have to consider in our design. So how much you want to store in CDN and how much you want to store in blob storage. Okay, fair. So let's move on to the next video uploading flow. So as we can see here, user can use multiple devices, TV, smartphone, and a laptop, and they can go and push the data into the original storage. Not sure how this works right now, but then a call is made to the transcoding servers. Maybe these servers are responsible for doing the encoding and stuff, like to make it uh, I mean encryption of the data and optimization of the video as per different formats. Maybe different formats can have different optimal things, and once the transcoding completes, it will push it into the queue. And so I think this is the upload flow, entire upload flow. So then you have some handler, and metadata cache would be, I'm just thinking that it would be kind of data where you're storing static things, maybe some thumbnail or some photo or something. And yeah, so some storage is happening at the CDN also. I think most of the storage is happening at CDN, almost everything. But what is the original storage? Okay, let's read it, what the author is trying to say here.
I think the primary storage is blob only, but the final product after transcoding and all these things, they are caching it on CDN finally, because our system is read heavy, so CDN is helping us on the read operations. than the processing and all is happening with the help of blob storage.
Okay. So,
Right.
what is this original storage? I still did not get it. Is it a blob storage?
So original storage
Yeah.
is the blob storage only, which is storing the raw data that we are uploading. But after that raw data is uploaded, the transcoding server is doing whatever uh,
Encoding.
encryption and encoding is required there, and storing it in a separate blob storage that is transcoded storage. And now CDN for CDN, that is the source of truth for those videos that user can stream from.
No, actually, transcoded videos are also stored in blob storage, and then like I mean, like depending on the like probably like someone can choose to different amount of to go for different amount of storage on CDN like a cache. So CDN is basically like acting as a cache only.
Right. And transcoded storage is a blob storage.
Yeah,
Yeah, right.
transcoded
That's
storage
also correct.
Yeah,
blob.
so I think what here is happening is when a user does some upload operation, then it gets stored into this original storage. From this original storage, these servers can pick up the data, and I mean, once they pick up the data, then they can store it into another blob storage. It is a transcoded data.
Yeah. So
And
take an example like suppose you are uploading a video that is like in a raw format. Let's suppose you have clicked from your iPhone, right, and the video is like let's say 500 600 MB, right. So now when you upload it, so that raw file will be stored, right. Now like that video will have like different versions, like it will be MP3 also, MP4, like MP3 MP4 and different encodings based on device, like what device supports what kind of encodings. So we can assume like typically one video can have like formats up to like not sure, let's take an example 16 to 20 and different encodings, right. So some might be like some in high resolution also, so 500 MB gets to converts to like 700 800 MB. So now if we take an example average like 500 into 20, so that much of different videos files are being stored, right. And so yeah, like that will be, so that has to be stored in the if now if you calculate the price on the blob storage, so that will be not sure like 5 cents or something like per GB, or what, like around, we can estimate like that kind of cost. So yeah, like we can multiply like what kind of cost comes for the blob storage, and then if we choose a CDN, then like what kind of cost comes in. So in interview we can discuss this point, that that's the trade-off we can call out.
I mean, I didn't understand one part, like this metadata cache, right? Metadata and metadata DB. So that is kind of some data, right? Some static or some data which we want. So why do we have to kind of do this after the queue is happening? Like when you're putting the message in the queue and then uploading it, you can do this part before also, right?
Actually, like yeah, like there are different type like metadata. So like if we just talk about the metadata, so that can be like for a video, like its artist name, album name, and like title and all these kind of information. But apart from these, like if when we will read further, so we'll get to know. So basically, these videos are splitted also, right? So that kind of information also we need to store.
Okay. So I think there is information about the resolution also. This information you can know
So
once you.
as per diagram, when the transcoding completes, then only it is stored in the metadata. We are not
Yeah.
storing it before that.
Yeah.
So just to be consistent, when we have a, let's say for MPEG 4 format completed on this storage, then only we will update in the metadata.
Hmm. Understood. And this makes sense also because you can get the correct resolution once the transcoding is completed, and based on that transcoding resolution, you have to update it into the cache and DB, the same thing. So then only you can add ones. So that is fine, I think. Yeah.
Okay.
Okay, let's move on. So this is again, videos are uploaded to original storage. We discussed this. Okay, and start transcoding. Okay. So this is like a asynchronous process, right? This transcoding which is happening.
Yeah, it had to be asynchronous because the point number one will take some time for the raw data to be pushed. And I think then point number two can happen if a video, a raw data upload is complete, then some notification can be sent from the blob storage to the transcoding service that this is done. So there should be some notification, and then only transcoding will start its part.
Okay. So completion handler is a bunch of workers that continuously pull event data from the queue. Like, I mean, has anyone like kind of worked on such scenarios, like in practically, like how do you do that, like this thing in real world, like uh, some handler and that is kind of pulling the data for you asynchronously.
So
If
this
you're just,
lambda, yeah, Vishal, you can go ahead.
so if you're just asking the queuing part, I have. If you are talking about this whole video encoding and those things, no, I haven't.
No,
Yes, sir.
So maybe this handler could be like lambda function of AWS, which is pulling, reading the statuses of different messages, and then like after, like they are only updating the metadata basically. Like for example, like maybe there was a video ID one, and its 360 pixel video has been transcoded. So one event we can get and update into this metadata DB. Uh, like these could be different lambda functions based on maybe partition ID could be a video ID and all.
Right.
Like my suggestion would be, like I mean, this like chapter talks in detail, like very much detail.
Okay.
Will be clear, like when we.
Okay, okay. Just questions are coming up because I haven't read it, so just asking. Okay, let's move on. Maybe it's covered.
Yeah, it's very covered. Like there are a lot of, I mean, jargons around. I mean, this encoding and all these processing. So
Okay.
get to read about that.
Okay, fine. So when a file is being uploaded to the original storage, the client in parallel sends a request to update the as shown in 14.6. Okay. Yeah, this is what I was talking about, right? You don't need to store it at the end. You can store some part here when you are doing. I think that is what they're talking about. You can store some information in the metadb at that time. So file name, format, etc. in the metadata cache and db. So there were two flows. First flow was, I think, to upload the actual video, and second flow was to update the metadata. These two are parallel, right? That is what they are saying.
Yes.
Okay, fine. So yeah, okay. Then in the video streaming flow, like how would you play the video? Then what is happening? That is a read request. So I think that uses kind of a UDP protocol, maybe where you are kind of trying to play the video, right? So UDP
No,
connection and packets would be coming in, and then that is how it's working, maybe.
no, I don't think so. They'll be using UDP protocol. UDP protocol is only used in like live. I would say like live streaming. I mean, yeah, live streaming or something like that. Because yeah, like mostly things happen on TCP protocol only.
Okay.
So I agree with Shubham. So UDP you need in live streaming because let's say you go offline, then your video should not start from the same exact point. Your packet should drop, and when you connect, it should again be live. So in UDP connection, you can afford to lose some packets in between because of your connection issue. But in video streaming, you cannot do that. Let's say I'm watching a movie, and at 10 minutes, I go offline. But when I resume, I should start from the same exact point, not from some other. So here we want a reliability that I should see those network packets from the same point where I got disconnected.
But how about the auto thing, right? That you have an auto feature. You are not playing on a one resolution. Okay,
Mhm.
so it can have multiple resolution, like based on the network bandwidth it switches, right? Sometimes it would come in HD quality, or sometimes it can be 360
Yeah.
pixels. So
That on the client side, like your client will can asynchronously like get to check the bandwidth, your network bandwidth, and based on that it can select from like metadata, like exactly like which kind of encoding and like format you need to fetch based on your network bandwidth.
okay,
But both are two separate questions. Like one is the UDP thing and second is this thing.
Yeah.
Both are two completely separate things.
okay. So like we can say that we will use TCP in this, right? Okay.
Yep. So by the way, like the author in this question, like in this design, hasn't like told the APIs basically, hasn't discussed the API.
Hmm.
Okay, good point. Yeah.
That's good. Let's read it completely and then figure out what
Yes.
the things missing and what we want to discuss. Maybe about extended requirement we can also discuss, but let's complete this first.
So the question I was thinking is like the streaming should be happening over a WebSocket, or it is like a HTTP streaming only.
No, WebSocket won't make sense here. So yeah, like there are like separate protocols like for streaming. Like that also we'll get to know.
Okay.
Okay.
But why WebSocket won't? I know WebSocket is not used for this streaming because it's just a one-way communication. But why it won't make sense? Let's say if I try to use WebSocket instead of HTTP streaming for a small chunk.
So like one thing is like assume the like scale at which like YouTube working. Let's say um, even 10 million users are watching at the same time. So managing 10 million WebSockets. And one more thing, like here, like basically client don't need to send anything, right?
Hmm.
It's
Yeah,
like
it's a one-way communication. I agree with that.
yeah, it's one way communication only. So we don't want to overspend or over engineer.
Yeah, so there are two options, but I agree that WebSocket is a expensive option, not the better one out of the all options we have. So we will not go with WebSocket. That I agree with.
Okay. Yeah. So here they are talking about some streaming protocols. Maybe there are some more optimized protocols that can be used. Maybe we can refer them. It's mentioned in some reference point 7. And okay, so the server which is closest to you will serve your request to minimize the latency for streaming purpose. Then let's deep dive. So here they are talking about the video transcoding for the uploading flow and video streaming flow. So when you're uploading, then some transcoding we saw that was happening in transcoding servers. So I think that is covered here. Bit rates and formats. Okay. So I've gone through this. So here they are talking about the benefits of transcoding. So one thing is the storage, like if you store, then there is a lot of space that it can consume, right? So we want to make it lightweight, and so that once the video is transcoded, so you can do the compression on that, and it will make it more compact and can support multiple video formats based on the user browser and stuff. So okay, so that is what I think they talked about, the compression and decompression. I don't understand this container, like what do you do with this container?
Container is more of like different video formats that your device will support. Right? So if you have used like iPhone, it supports it has some different kind of file
Oh,
format.
is it?
So it's
Okay.
way of storing, matlab, like way of storing the data in the file.
Agreed. And even
And
I think different softwares have some different way of, for example, VLC media might process your, but here I think it's VLC media doesn't come in picture because you are doing on the platform itself. But on the device, yeah, I agree. Like a different device, the format would be different, even in different browsers. I guess how Safari plays the video would be completely different from how, I mean, Google Chrome plays it, right?
yeah, so exactly like VLC is a media player. So exactly like your browser will also have like some kind of a media player installed. Like earlier, you used to require like download Adobe Flash Player and all that to watch a video.
Okay, understood.
So nowadays, like browser already includes that.
And here they talk about bit rates and stuff also, like in the transcoding you can uh, on the basis of bit rates. So is this a configurable field? I mean, this bit rate.
Yes, and client configures it based on your network bandwidth and as well as client the display size. So it can configure based on that.
Okay. I mean, it will be auto configured like based on the network and
Yeah, client does it for the user.
yeah.
Like user
Okay.
does not know anything.
Yeah, understood. Like even in YouTube Studio, you get an option where you can select like how much resolution you want for that particular video and quality of the video, something like that you can choose there. So yeah, that is what the client is choosing while before uploading the actual video. So based on that, it will, I think, do the processing of this transcoding part.
Just to be clear, I think this is only for downloading purpose, for streaming purpose, not for upload. Like
No,
upload.
I think it is for uploading, right?
Okay.
This is talking about the upload
Yeah.
flow.
Okay. Sorry.
Okay. So this is the transcoding flow. I think we have covered a lot of things. Now let's move on to the DAG model.
Yeah. So majority of processing happens on upload flow only. Streaming flow is just like get the like your client will share the send the configuration of your device, what it supports, and then based on that, it will like fetch different file format and codec formats.
So where is this happening, at the transcoding service or at the client level while uploading?
Actually, uploading also like it's talking about that. Basically these DAGs and all these creations are happening at the client level.
At the client level. I have to read this part again. Design details. Okay.
Yeah, I think just they are diving deep, like how would it happen. So once your original video is there, then within the transcoding, the video would have certain task, inspection, video, uh, transcoding, and thumbnail. But what is this thing that I didn't understand this DAG model? Is it like a dependency, something that this will happen first and this,
Yeah,
some dependency kind of thing?
yeah, right. So exactly, yeah, like for our video, yeah, like this is how like basically they store information. Like first this task has to happen, and then this task has to happen. So kind of a directed acyclic graph they create
Okay, understood.
of the tasks,
Yeah, got it.
and then yeah.
So I believe these are just API calls, and you can in your software or your service you can define that these are my tasks. It is dependent on this task, and task
Mm,
can happen parallelly, and at last you can get response. So another task will resume only when the dependent tasks are completed. Something like that can happen here. Just
yeah.
to achieve parallelism, I think there are a lot of tasks. So to make it fast, you have to kind of do this dependency thing. It is one option, but there could be more other options also.
Yeah. So not completely sure like if this happens on the client side or server side, but yeah, like I mean probably like it will be clear like along the way.
Yeah, I just read it this part.
Okay.
It is on the server side only. The transcoding service is doing this after the log data is uploaded.
Hmm.
Okay. Okay. Then client just creates that directed acyclic graph,
Just
and
a yeah.
server uses like probably some
Yeah,
work heads, and they can use. Yeah.
and even I think the audio, right? So in audio also you have to process it and stuff like that. So that also has a different I mean service actually we can say for processing of the audio and encoding and all.
So what do we mean here? Like client computes this directed acyclic graph, like, or this would be configurable basically.
This is at the server side, not at the client side.
Yes, right.
Hmm.
Not really sure. Like okay, let's read it. Probably we'll get some clarity.
So yeah, so this happens during upload flow only, no? All these things, directed acyclic graph.
Yes.
Mhm.
Okay, so yeah, so I mean let's move on. Maybe we can check. Maybe it's covered later. So video encodings can, again, these are the formats, and then how you are doing it is here: preprocessor, then DAG scheduler, then you finally get an encoded video. Okay, what was the earlier thing? It was a DAG model, which was this. Maybe could be this, right? Okay, maybe it's very high level. They have actually not gone deep, like why they have chosen this, why they have made this decision to use it. But it shows like one of the way how you can handle the parallel things, but not a decision we have taken that why we are doing something concrete is not there actually.
Yeah, I think this could be done in a workflows way also. Like normally they have defined a workflow basically,
Hmm.
but there are custom third party tools for.
So DAG model is also a workflow. It just looks like a directed acyclic graph. And when you imagine workflow, you think of it as a sequential pipeline. But both are kind of the workflow thing only. DAG just supports the parallel processing as well during those workflow.
Mhm.
Okay, so then let's move on the preprocessor part. Oh, they have discussed everything in detail. So this is, I think, quite detailed. So what does preprocessor does? It splits the video into smaller chunks,
Can
and
go back to the architecture. Like let's the next page.
previous page.
Yeah, just this one only. The video transcoding architecture. No, next page. Sorry. Yeah. Next page. Yeah. So this one, the video transcoding architecture. So basically, it includes preprocessor.
Hmm.
So first of all, they push some files to the temporary storage, and then I think probably like at each level of processing, after each level of processing, they could be storing it some temporary storage. So from preprocessor, it goes to DAG scheduler. Then we have like resource manager. Then we have like all these task workers. So task workers they mentioned earlier, like inspection, video encoding, thumbnail, and all these. And then and then yeah, like finally after task workers do all the processing, then the encoded video. I mean, yeah, like next part is the encoded video in the okay that comes out as the output.
Okay,
So now
so yeah,
they will talk about each component of that.
so I think there are one, two, three, four, five components, right?
Yeah.
So yeah, let's go. So now we are talking about preprocessor. So it divides the data, and this chunk can be played is an independent unit, and then it creates a DAG.
So it's saying second point, some old devices or browsers might not support video splitting. So I mean, like essentially, like this video splitting is happening at the device level. Preprocessor split videos by GOP alignment for old client. Okay, understood. So either like the device will split those videos into like multiple like different chunks, individual chunks. If that device cannot do that, then basically preprocessor will be doing that task. Okay, and they will split by GOP alignment. Okay, and then like it will be responsible for DAG generation also. Okay.
But
So ba-
what is this download thing, right? In preprocessor,
so
why you want to download the data?
so yeah, like there are like multiple. So let's assume like we have like one whole long video of 100. 1 GB. So now it's split into multiple chunks, 100 MB, 100 MB each.
Mm-hmm.
So like after each level of processing, let's say um, like someone okay, like take any task that was there. So basically, after that task is complete, that file needs to be saved somewhere so that like asynchronously, like next task can download that like based on its like previous like what was previous task. So based on that, like it can identify the file name, download that respective file from the temporary storage, and then do next processing, right? So
Yeah,
this
so I feel like why they are doing DAG thing is to kind of make it into a tree structure rather than a linked list. So that the time complexity wise it is more optimized if you process a tree instead of a linked list. You could have done this in a sequential manner, right? You could have a linked list, split it the chunk, and the dependency is direct, right? There is no graph basically you don't need there.
yeah.
And how do you define an edge? That is still an open question that is not defined here.
Uh, so yeah, like just so essentially, like okay, you can understand this way. Like one DAG represents basically one configuration file. So the configuration files, what does it say? Like task, like name, download, input. So basically, it will download. Type is download, and it will define input, and it will define the output,
Okay.
right? And then the next, like what is the next task? So it's yeah, like kind of like this task would be like one node. Now the next information is basically the next node is a transcode node, right? And from this task config you get to know like what is the, I mean, you can define that as an edge, right?
Okay. Okay, basically in a file, if you see,
Yeah.
then I'm still not getting it, but anyways, I'll check that maybe later. Yeah.
Can't we take this like as like the same example? Like we have a flow in e-commerce also. Like when somebody purchases a product, the order gets created, then there's a shipment, then shipment confirmations. So these happens in a step or in a workflow. The same kind of workflow, can't we think in the same way? Like there is a process in a e-commerce also. Like same
Uh,
process.
yeah, we can think it, but there you have different flows, so that is why you have different dependencies and stuff. Here you have a single video and you have divided it into chunks, and each chunk would be processed separately. That I agree, but why you need DAG? That is like what we are achieving from it. That I'm not clear on that.
I think this is like just one of the architecture
Mm-hmm.
they have, that where they have used this DAG model, right? They created these tasks as a DAG, I mean
Okay, okay,
the-
sure. So, okay, fine. Let's move on. Maybe it will make more sense if I move ahead. Maybe they have covered it. So, yeah. So, cache the data, segmented videos. So, you are dividing it, and then for better readability, the preprocessor stores GOP and metadata and temporary storage. Okay. Then the scheduler. Preprocessor is responsible
What is
for
temporary storage? And blob storage or some kind other kind of storage?
this cache.
No, temporary storage.
yeah, that also should be a blob storage only.
Oh, okay. Yeah, okay, you can continue.
Okay, so yeah, so it divides the video, the scheduler. First, it will create a DAG out of it, like how what is the dependency, and then that DAG would get executed into a queue or something. Okay, okay. So the videos get splits into three parts: video, audio, and metadata. Okay,
Yeah, like these all stages will be like defined in the like our DAG config files, like in those config files.
mm-hmm.
And then scheduler can pick like one by one task, and then yeah, like and then basically push it into, so yeah, like that can happen in parallel, right?
Okay.
What is metadata? Okay.
Metadata could be like your thumbnail or some user related information or some video related information like video title and stuff like that.
Yeah. So yeah, like probably here metadata could be like after the video is split into chunks. So now like you need to have some kind of information, right? Like this that defines the like one information would be like the order of the chunks. Like chunk one would come first, and then chunk two, how they are connected.
Okay.
Okay, where is that here in this metadata? I'm not seeing that. Maybe
Yeah.
here we discussed, right? So above we discussed. Here we were discussing metadata.
No, that is a separate metadata.
Okay.
She was talking about the metadata of the particular video that we had in the diagram.
Okay. Okay, this data. Okay, got it. This metadata. Fine. Okay, fine. So here, what they said about this. Sure. Okay, that's fine. Let's continue. Then you have a resource manager. I think it's a too much detail, right? They are just trying to make us understand like what is happening internally. Then a worker queue, running queue, different kind of queues can be there. It is like basically a scheduler, like how you want to. So priority task would be executed first, and then the tasks which are running, which will be in the running queue. Okay. Basically, which are in progress would be here, and worker queue is like a priority queue that contains worker utilization info that has a different queue. And task workers can kind of do this thing. Okay.
I think this is the least threads maybe.
Hmm.
But do we have to go to this level to
No, I don't think so.
sign in code at the worker level?
uh,
No, right?
yeah, like in an actual interview, I don't think that all this is required at all, and even you don't get so much time, right? So it's just about like to give us an idea like how things could be working behind the scenes.
I mean, yeah, like knowing is a good thing. Like if interviewer goes in like deep diving on any of the component, then we can touch the. Oh, okay, like one of my interpretation is like not, is that like so here it has like different priority queues, right? And basically there is different priority associated with any task, right? So I'm assuming like how this can be designed. So let's say like I have like one of the chunk. So now like let's say the first task is to let's say inspect, and the second task is to let's say what like transcode and then watermark, right? So like I can give highest priority to inspect, and then a lower priority to transcode, and lower priority to like watermark.
Mm-hmm.
Now what will happen, like how these things will be working. So let's say like once like this DAG is created, so now like I have let's say 10 chunks of my video file. Okay, so now for each video chunk, these three stages that I need to execute: first inspect, then transcode, and then watermark, right? So now, so everything is in our task queue, right? So now our task scheduler will pick the highest priority. So how it will happen, like highest priority task. So now like these things has to be happen in a sequence, right? um, so it will first pick the all the inspect related tasks, right? And after performing those inspect tasks, I mean these all are like running in parallel, right? So let's say for chunk one, inspect task has happened, and it has pushed the transform file to some temporary storage. Now similarly like all 10 will be processed, right? And then my lower priority would be this thing, like after inspection, this transcoding. So then like any transcoding task will be happen, will be pick up, the transcoding task will be pick up. So it could be for split sorry like chunk one, chunk four, or any of the chunk, right? So this can ensure the order of these tasks, and it can similarly happen in parallel also.
Okay.
Like did I make any sense? Mm.
Yeah, I understood. Like you are trying to say that there would be different workers. So each chunk would have certain set of workers, and it has to execute certain tasks. And these tasks would be assigned some priority, and on that basis, like each chunk
Or
would be processed and based on the priority. So if the priority is high, so that those tasks would be executed first, and we are done with it. Then another would execute something like that.
yeah, so basically this way we can ensure the order, like order of any chunk, and simultaneously like we can do processing in parallel also, right?
Yeah, and this is we were discussing about.
I had just one question. Why are they using different queues for different priority? Uh, like in the diagram.
So I don't think they are using different queue. They are just using a running queue and one priority queue for the task queue and one worker queue. So worker queue is a different this thing, priority queue, which is a kind of a utilization info. I'm not really sure why that is a priority queue, but maybe it holds some information about these workers.
So task queue, it is a priority queue that contains tasks to be executed. So basically, task queue has like all the tasks basically, and basically it's a like priority queue, right? So like chunk one inspect, so that is like highest priority. So yeah, like basically it's a priority queue, and all the tasks are there in this queue. Now,
No, I think the question is that why we are using two priority queue. Yeah, is that the question?
Yeah, like multiple priority queues.
Yeah, so for different reason they are using different priority queues maybe, but they're not talking in detail about this, like what is the purpose of this worker queue.
so,
So maybe get the optimal worker, they are saying, like there are multiple workers, so which one is the optimal?
So workers has actual instances that are running those tasks. So based on their utilization, like how much CPU usage and those all have, you can pick it from priority queue. The task scheduler will do it, and it will pick any task from the task queue
yes,
based on the priority, and then it will assign that task to that particular worker that it picked from those two separate queues, and it will put them in a running queue. So there are three queues involved here: one for the task pool, one is for the worker pool, and one is for the running
yeah.
jobs.
Yeah, so just assume like we have 20 tasks, right? And then we have like, let's say 10 nodes which can act as a worker, right? And let's say at any instance, like 4 or 5 workers are basically currently processing, right? So now let's say this scheduler, what it does, it picks like, let's say the top priority task, and then it picks top priority worker from that worker queue, and these workers are available worker that can process. Now when it has pushed that task into the work, like pass that task to the worker that now process this, and then at that time it will add the queue information, that sorry, add that worker information in this running queue, that okay, this my worker one, let's say worker one node xyz is processing let's say task abc, right? And that information, so basically that worker is now pushed to the running queue, right? Now after this like the processing is completed, so that will be pushed back to the worker queue. Now that is available to process any next task. So now task scheduler can get that corresponding available worker.
Yeah, understood. Yeah.
worker
So what is happening is, let's say you get a priority task. Okay, you will see that which task I need to execute on priority first. Then what you will do, you will see that which worker can execute that task, right? That information you can get from this worker queue, that which is available and which has more optimum, that you can pick up, and that can be put into the running queue. Then this task can be put into a running queue, and then that can be used, I mean, to process that task worker and task queue.
Yeah. Yeah, like one thing I missed out. So basically, yeah, like from here, what it seems like, basically, like I have some node XYZ. Let's say it has capacity to perform, like say, 3 to 4 tasks, right? At the same time, right? So basically, that will like identify CPU and like memory usage. Yeah.
Okay.
And how can we make a normal queue as a priority queue? Like, is it supported with like maybe SQS or Kafka or RabbitMQ?
I'm not aware actually on that.
Okay.
Yeah, so maybe it's possible like SQS might have those capability to assign priority queues, but I'm not very sure. Maybe we can read about it.
Uh-huh.
Okay, let's move on. I think how much is left, because we are already 1 hour. I think only 3 slides are pending. So let's quickly cover this. So once the encoded video is there, that is the final output, and then some optimizations. The whole unit is inefficient, smaller chunks. GOP, what's GOP? I don't know this.
This is like group of pictures.
Okay.
So yeah, like your yeah, like let's say a group of pictures could be like your video file from let's say 1 minute to let's say 120 seconds or
Okay.
something.
Okay. Got
So
it.
Chunking
uh,
of
yeah, so video is essentially a chunk of like frames, photos, right? Yeah.
And it is happening at the client side. That is also quite interesting.
Yeah.
So how would it improve the speed? So this allows fast resumable uploads. So we are still talking about the upload flow. So
Mm.
okay, so it kind of divides it and then send it to the storage. But here the transcoding has not happened. Transcoding is still happening at the server side.
Yeah.
Okay, these are some optimal. Maybe we can read about it, or maybe definitely they have referred from somewhere. So maybe we can check that what is this GOP thing, and why actually we are doing it on server client side. Okay, multiple regional can be chosen to optimize it. We are just dividing it. Okay, so low latency, then so how we are storing it into CDN. So you get an original storage, encoded videos are then sent to upload, then to the CDN. it's basically the transcoding layer they have abstracted out. Message queues. So it goes to the message queues. Okay, just to add it into the message queue for each module, I think each chunk maybe. Yeah. Okay, they are here basically talking about different optimizations. So encoding, I mean the speed to parallelize within the do some client side GOP thing to optimize the upload. Then another way to optimize it to do the upload centers close to the users, so that the network bandwidth cost is saved. Then in the speed optimization, they are trying to parallelize everything, and to make it loosely coupled, they are introducing message queues as well, so that these two are not dependent. They are dependent on message queues. Okay. So then once you have a so I just want to understand one thing, like let's say when you are um, posting some image, right, on a social media or somewhere, then you have that URL thing generated, right? So that URL, image URL, you're storing anywhere in S3, but how that URL gets generated, like does it get generated at the client side, or
No.
how does that image data basically goes through an API? That I want to understand.
So, exactly, like basically what happens is like your client will first make a request that you want to upload your this particular media file, right?
Okay.
When server gets the request, it first like generates a placeholder URL,
Okay.
place URL. Maybe let's for simplicity understand like server will create one folder,
Mm-hmm.
or three, and then it can make it as a pre-signed, right? It can create some token for that, and then basically like send the response to the client that this is your URL. I mean the URL can itself contain um, URL can itself contain some like token that basically authentic, I mean some authentication token,
Mm-hmm.
right? So now client got the URL of the S3 storage, right? Some S3 folder which is authenticated also, like it has the token. Now it will just like call the S3, client can make the like S3 upload call.
Okay, S3 upload call is fine, but the actual image data, like how does it go? Like, is it like in form of some binary pixels, or how is it binary data?
So it's like I mean I have done on the like on the application side. So
Mm-hmm.
basically what happens is like you just mention the the file URL on your device,
Okay.
and then that file, I mean again that file can just go in as a like HTTPS in the HTTPS request.
Okay.
So you have used the Postman, right?
Yeah.
In the Postman, I think like one of the option you get, right, like I think raw data or some like
Mm-hmm. Yeah. Yeah.
so there is the option.
Okay. So yeah. So I was just trying to understand like how you upload an image, right, to a remote server. So yeah. So okay. Thanks for that. So maybe we can continue. So safety optimization is like encryption and stuff. So they are talking about it. So that is fine. I think that is just some details. Then cost saving optimization, CDN, which is expensive and data size is large. So they talk about YouTube video streams follow long tall distribution. Popular videos are accessed infrequently. Most popular from the CDN. Okay. So the most popular videos will route to CDN. Others can route to video servers. ISPs can also like Comcast this. Okay, viewing experience can be improved, but not that storage thing. You can store the data at the ISP itself. I think that is what Netflix also does. Hello. Yeah, so are you guys here?
Yeah, yeah.
Okay, okay, fine. So yeah, then we can have these error handling things. So that is, I think, is there. And yeah, I think we discussed about all these things. Scaling the database we can use through database replication and sharding. Then API servers are stateless here. It is easy to scale horizontally. Then it refers to the process. Okay, so how this is getting broadcasted. Okay, this is a really interesting design. I would like to read more about it. That how do you scale it for a live streaming? Like how is it different from the actual upload, right? So here they are saying that everything happens on a real-time basis. So I think this is a very unique and interesting problem to learn about, like how these systems actually do that processing in real time. And it should be really, really for resistant also, right? Because you cannot afford any error handling. So video takedowns, and I think we are done here. So thank you guys. I mean, like it was a good session. There are some these links.
So this like all the this architecture, like DAG architecture and all this,
Mhm.
was basically inspired